Hello, and welcome to the video presentation of Mountaintop Mining Explorer, a standalone GIS program developed by Matt Sagibo and Ryan Moore for Dr. Ames's GIS programming class at Brigham Young University. Mountaintop Mining Explorer is a simple standalone geospatial tool developed for Windows with C# and DotSpatial. The purpose of the program is to estimate the volume of material to be removed from a user-specified region. This is achieved by having the user load a DEM of the area they wish to analyze, and then draw the area they wish to remove material from. Mountaintop Mining Explorer can be found on SourceForge. If you would like to download a copy, a link to the project page is available on screen and in the description below. To download the program, you simply have to click the Download button on the main project page. Once the download has completed, you'll need to unzip the file. Once the file has been decompressed, you are free to run the program. Now Matt will demonstrate how to use the program.
Here is our standalone application. It's called Mountaintop Mining Explorer. You can see in the top left of our program. And the purpose of this is it allows a user to import a DEM of a potential mining location, then draw the polygon representing the proposed mining cut, then compute the volume of the material that needs to be removed, and create and kind of like update the DEM of showing where the cut is made and where the fill is placed. So I will walk you through how to use our program. So first step is you need to add the DEM. So if we click here, I have a DEM just of a part of Utah right here. So hit open. Shows the status of the DEM being uploaded to the program, and then it will show up right here. So right here we can see the elevations of the raster and kind of be able to tell where the low points and the high points are. We are also able to kind of zoom in and zoom out using these tools. And so there's the zoom in, there's the zoom out, and next we need to draw the cut region where we want the new mine to be placed. So I will draw one right here. So you can see how there's this blue dotted line. It's kind of just showing your potential line for the polygon. And when you single click, it places that line, and then at the very end you double click and it fills in the polygon and it shows the name of the cut. Next we will need to place the fill region. So same actions, click, click, and then double click. Shows the fill shape. And then right here we get to place the elevation that we want this mine to be, the new mine to be cut. So we look over here, we can kind of tell the elevations that we have, and so let's say we want to place a mine at the elevation of 2000. And one thing I forgot to mention is down here in the bottom left hand corner you can see the X and Y. It's being displayed so you can know exactly where you're placing these corners of your polygon. So you can place the mine, let's say you knew a specified X and Y coordinate, you could place those corners and see where your mouse is hovering over. So now that these two layers are placed, we are able to calculate the volume of the cut and then place the material from here and put it over in the fill. So after that was done processing, this message box pops up showing the calculated cut volume. And I will not try to say this number, it's kind of big, but that's how many cubic meters of the material that was calculated from the cut. So when we hit OK, we're able to kind of see these fill and cut rasters. And so you're able to see the cut, so you can see how low it is. It's kind of that, that color for that 2000 elevation that we specified. And then that volume was placed on top of this fill area. So it's kind of just filling in these, the space over here. And so that is our program.
Now we will present the code of the program. First, I will discuss the user interface and the basic layout of the program. The UI is fairly simple, with a DotSpatial file tree on the left and the main map window on the right. The File menu is likewise simple, with an exit button that closes the application and a new button that resets the program. The Help menu has three options. The first two options display the user manual and the technical design documents, respectively. The third option displays an About box. This box shows basic information about the program and the license. The tool strip has a bit more complexity. First, there is an Add DEM button that brings up a File Open dialog to allow the user to select the DEM they wish to use. Then, there is a Zoom In and Zoom Out button. These are quite simple and allow the user to zoom in and out of the map. Finally, there are the Mine Region and Volume buttons. And for those, I will turn the time over to Matt.
Okay, so I am here to explain the polygon buttons here and also the cut and fill calculator. And so if we look here at the code, we can see what happens when you click on the mine cut button. It will pop up this message box right here, kind of explaining how to be able to create this polygon. It will also turn on this polygon digitizing, just letting it know that we are drawing on the DEM, and then it will tell the polytype that it's the cut, and the same thing happens with the fill polygon message box, the digitizing, but then it will say that it's a fill polygon type compared to the cut. And so if we come down here, we can see what happens when you first click on the map. It will create this point right here, take the coordinates of that point and add it to the list of digitized points. And then this invalidate kind of just makes the whole map as invalid points and lets you kind of show this dashed blue line. When you're moving the mouse, it will also kind of display these X and Y coordinates down here in the left hand corner. And so that's the text we needed to use to populate this tool strip down here in the left hand corner. And so again, this invalidate function is right here just to be able to allow for this blue dashed line. And then the paint function right here is just there to for the coloring of the lines. So we can click again, it changes, and it's kind of doing that click function that we were showing. And then the last thing is this double click. So the double click again will take the last point that you click, take the coordinates, add it to the list. It will turn off the digitizing, so to let it know that you're done. And then whether the polygon type was put as cut or fill, so that's just when you click on the buttons, it will save that polygon either as a cut dot shape or a fill dot shape, just so you can refer to that later for different functions. And so those are how you're able to draw the polygons. Now coming down to the calculate and cut and fill of the cut and fill volume, we kind of declare some of the variables right here. The first thing that happens when you do click on this button is it checks to see if there is a DEM already loaded. If there is not a DEM loaded, it will ask you to add that because the calculator won't be able to work without one. And then kind of some setup variables right here. And the one thing that we had to do is we had to import the this user inputted mine elevation. So it had to convert that text into an integer to be able to use it. And the first part of our function had to create a copy of the existing raster and kind of take the bounds and the projection of that raster, and so we could be able to manipulate that raster. We had to get the cell size, so we calculated the area of the hole, the DEM and divided by the number of cells so we can know the cell size. And then we were able to finally make the cuts with that cut polygon we drew. And so using the cut polygon we drew and the mine elevation, it goes through this loop to see if each raster intersects a polygon first, and kind of puts it into this other if statement saying if the elevation at that point is either above or below the cut elevation and what to do with it. And so if it is above the cut elevation, it will take away that material. And if it's below, it will kind of just leave it alone. And then if it's outside the polygon, it will also again leave alone those elevations. And when we do make a cut though, we want to save that cut from that point and place it into this equation to be able to calculate the end cut volume. And again, we go through the same process with the fill raster, but the only thing is, since it is a different shape, we need to calculate again those different cells and distribute evenly the cut over the fill area. And so this is what we do right here. So this is where it looks over each of the cells and it distributes them evenly. And the last part that we had to do is we had to display these new rasters that of the cut and fill at the end, and then also display the message box showing the calculated cut volume.
Thank you for taking the time to watch this video and learn about Mountaintop Mining Explorer. We hope that you found this presentation informative, and we hope that you have a good day. This concludes the video presentation of Mountaintop Mining Explorer.